This is my Leaving Cert computer science project. My project is based on a wildfire risk monitoring system. It uses a microbit with environmental sensors to collect temperature, humidity, and soil moisture data. This data is processed to calculate a wildfire risk percentage, which is then displayed on an OLED screen. For this project, I use an IoT environmental board, a microbit, a DHT sensor, a soil moisture sensor, and an OLED screen. My system includes both digital and analog inputs and produces an output also. The buttons on the microbit act as digital inputs, allowing the user to interact with the system. When buttons A and B are pressed, they show the wildfire risk percentage to the user. When buttons A is pressed, it resets the risk percentage to 0. The sensors attached act as analog inputs as they output a range of values depending on the environment. The system produces an output using an OLED display as seen here. The sensors connected to the microbit collect temperature, humidity, and soil moisture data. This data was recorded using the microbit's data logger and stored then as a CSV file. This file is then used in Python to create graphs based on wildfire risk with my 3 factors. My system simulates wildfire risk based on the conditions I measured. As temperature increases and humidity and soil moisture decrease, the wildfire risk overall increases. I tested the system under different conditions to simulate real-world environmental changes, and this is seen in my black box testing. This is clearly seen on the OLED screen. For example, when the temperature drastically increases, there is also a major increase in the wildfire risk percentage. My model is a wildfire risk calculation that I created on my microbit, where the sensor data is processed to produce a risk value. The OLED display shows the output of my model. This data collected from my microbit was then exported as a CSV file and used in Python to generate graphs and analyze the relationship between my chosen factors and wildfire risk. The threshold lines I put on these graphs demonstrated that if my temp factor goes above the threshold line, there is a wildfire risk, and if my humidity or soil go below these lines, there is also a wildfire risk. I created 2 what-if simulations on Python, which were both able to be adjusted by the user to change variables, and then a wildfire risk would be displayed based on the variables changed. My first what-if scenario allowed the user to adjust my 3 variables and then be given a wildfire risk likelihood. My second what-if scenario added in a 4th variable, wind speed, which could be changed by the user to get a wildfire risk likelihood, while keeping my other 3 factors constant. By allowing the user to input their own measurements, I essentially allowed the user to create a variety of their own what-if scenarios. My system adapts to changing environmental conditions by continuously updating the wildfire risk based on real-time sensor data. This allows my system to respond dynamically to changes in the environment. In addition to this, the design of the embedded system is flexible, as new factors such as wind speed could be added by modifying the algorithm and integrating additional sensors. This means the system could be extended for more accurate predictions or scaled for real-world use. The main challenge I faced was combining the sensor data into a single wildfire risk value. It was difficult to decide how much weight each factor should have. However, I overcame this by testing different values and refining the algorithm until the outputs were realistic. My system is efficient as it processes sensor data and calculates wildfire risk instantly. This is helpful as it allows real-time monitoring, which is important in situations where conditions can change quickly. The system is also user-friendly, as the wildfire risk is clearly displayed on the OLED screen, allowing the users to easily understand the results. Overall, my project successfully meets the requirements of the brief by collecting environmental data, processing it, and displaying a wildfire risk to the user. The system performed reliably during testing also. While there are some limitations, such as there only being 3 factors measured, it demonstrates an effective model for predicting wildfire risk.